Welcome to this latest video in Programming Fundamentals. In this video, we're going to explore the basic fundamental principles of sequence, selection, and iteration. Things like variables versus constants, and also how we input and output data using arithmetic operators and logical operators. So we've got quite a lot of ground to cover. In this first question here, we are looking at the concept of variables and constants. So that's going to come up in this exam question here. The area of a circle is calculated using the formula pi times r squared, where pi is equal to 3.142 and r is the radius. So this is, I'm sure, a calculation that we're all very familiar with that we have used in maths. Finn has written a program to allow a user to enter the radius of a circle as a whole number. If we're thinking whole number, by the way, we're thinking it should be what data type? We're thinking it's an integer. And it's going to then output the area of a circle. And you can see here that this is the code. Now, something I want to draw your attention to is that it is not quite the syntax of something like Python. So for instance, this should be indented, shouldn't it, if it's inside an if statement? It shouldn't have the word then. It should have the colon. But I think we can appreciate this is basically the exam, I think what the the OCR official exam language, which is not a real language. It's the OCR exam language. However, I think we can look at this and realize that it's close enough to something like Python for us to understand it pretty straightforward. Yes? Anyway, it's going to set a variable called radius, set it to 0, set a area to 0.0. This is going to be a real number. A real number is a number that has decimal places. That's right. Okay, so integer, whole number. A real number is a number that's decimal places, otherwise sometimes referred to as a floating number, a float. And then it's going to ask you to input the radius. So that's going to ask you to again, this would be different to how it's done in Python. In Python, it would be radius equals input, open brackets, close brackets. Yep. But it's storing what the radius is going to be. And then if the radius is less than 1 or higher than 30, then say the radius is invalid, because it's checking the size, isn't it? And it's saying if it's too large or too small, it's outside this, because it says that the number should be between 1 and 30, and then it says, if it's that, sorry, it's too large. Otherwise, it calculates it using the calculation there. That symbol there, if you're wondering, that's to the power of. So that's to the power of 2, otherwise known as squaring a number. And then at the end of this, it will then print the area and end if. It's going to ask you to identify 2 places where a variable is used. So 2 variables you can identify, but also it's saying that constants haven't been used, but a constant could have been used, but where? So it's asking you to figure out the difference between a variable. If you remember, a variable is something that varies, that changes. Clue is in the name. And a constant is a value that stays the same, does not change. Okay? So I need you to look through that code and figure out where it is that you see 2 variables to start off with, 2 marks easy, and then 1 item that could have been a constant, and the reason why it could have been a constant. So let's have a quick look through and first of all explore the variables. Variables, as we just discussed, are things that change. Now in here we can see that radius is initially set to the value of 0, and the area is set to the value of 0.0 because it's a real number. Later on we can see that somebody then inputs a radius, and that could be any number, hopefully a number between 1 and 30, but you can imagine it's not going to be 0, so therefore radius is certainly one of the variables because it changes. The area is then calculated based on the radius, so the area is going to change to whatever the calculation was. So the 2 variables we can identify are radius and area. When we're looking for a constant, we're looking for somewhere where it's storing a value just like a variable, but this time it stays the same and it doesn't change. Okay, so somewhere where we're using a value and it doesn't change. So a suggestion from the audience is that we might use the value of pi here, and we could store that. So for instance, we could add in an additional line at the top potentially. Ooh, let me zoom in. So we could set pi as being a constant. What value would we associate with it? No, what's the value we're going to use? 3.142. And then down here, what would we change that to? Pi, right? So from now on, we change that to pi. And then let's say later on, you wanted to have more decimal places of precision, then you could just change the value here and it would automatically update, wouldn't it? Is the value of pi going to change at any time in the future? No. But yeah, we could have more precision, couldn't we? But the actual intrinsic value of pi stays the same. Potentially, by the way, what about here? You know, the lower limit of 1 and the higher limit of 30, could that be a constant? Absolutely, right? I think there's stronger arguments for pi, but then you could say, because during the code, are they changing 1 and 30? No, so they could also be arguments for times where you'd want to potentially make those as, what did we say they were going to be? Constants, okay? So if we picked 3.142, we could say that that could be a constant, but what's our reason for it? The reason is the value does not change as we go through it. In this problem, what we've been given is a flowchart, and the flowchart indicates the logic behind the algorithm. We have to be used to some of these shapes. The rounded rectangle indicates a start or stop shape. So obviously one at the start, one at the stop, and you start at the start. The parallelogram, that is a shape that indicates either a data is being inputted or outputted. And then in this shape here, this rectangle, that's a process. That means it's going to do something. And what it's asking us to do is to be able to read through this algorithm and follow the logic. So Tom, which would be the first name, Ward, which would be the surname, is put into this system here. And it's saying name equals left first name 3. Now, and even if you're not too sure what that means exactly, you can see first name is going to be Tom, and then left 3 ends up with Tom. So assuming what it does is it takes the left up into the third character. So 1, 2, 3, that's the third character there. It gets you the first 3 characters on the left-hand side. And then you get the first name, and you add it to the second name, which is Ward, and this time you take the first 2, so it would be W and A, and you see it's T-O-M-W-A, capital W, of course. And then output it. We need to do the same with Rebecca. So Rebecca's first name is going to be Rebecca. Can you see what this function is going to end up doing? So left, Rebecca, comma, 3. That's right. It's going to give you the first 3 letters. Ooh, I can do that better. So that's going to give you Reb. Remember, again, look, it's capital R, lowercase e and b. And then it's saying do the same with Ellis. So Ellis is going to get added on here. Ellis, comma, 2. So it'll be the first 2 letters of Ellis, but stuck onto Reb. So that's going to give you Reb, capital E, L. Associated with variables is the concept of data types. All data is held as what inside a computer? Ones and zeros. But sometimes those ones and zeros could represent a number. Sometimes it'd be a whole number, maybe a number of decimal places, maybe it's a character, maybe it's sound, etc. And data types are used to represent it. This is a card. So when a customer pays using a card, such as the one below, shops use computer systems to process the payment. So this is our card. And it's saying in here, tick one box in each row, so just tick once, to show which of the data types given is the most appropriate data type for each of the following data items. So go along here, the amount paid, the customer's card number, and when the payment is made, and try and pick one you think is appropriate. So let's have a look at it here. The first one it's asking us to review is the amount paid. Now, the amount paid, does that appear anywhere on this card here? No, so it's a bit of like what we call a red herring. But the amount paid will be in what? So it'll be in pounds and pence, right? And ultimately, if you stored that as an integer, I suppose you could, you can store it in the whole number of pence, but realistically, it'll be a real number because you want to store it in, pounds dot however many pence. Sometimes, in some programming languages, there's an additional data type which is called currency, which would make sense in this context, but we don't have it in this one here. The next one here is the customer's card number. Where's that on here? Boom, there we go. Now, what do you think we could use to store that as? See, now this is the one where it's trying to trip you up. You might think it's appropriate to store it as an integer, and I can totally see why. Here's your issue with an integer. Have you gone into a calculator and start putting in a number and start putting in loads of zeros? It won't do it, will it? It won't store it, because it'll be like, what's that? FYI, another classic, is a phone number. What data type do you think a phone number would be? Also a string. Because, I mean, actually, this is tricky because my normal other explanation is saying if you do a calculation on it, it's an integer. And actually, there is a calculation done on this to create what's called the checksum, but you still need to store it as a string, and it'll get cast as an int to do the calculation. So what was it? It was string. So for the final question, it's when the payment is made. Does this exist on the card here? No. So this is going to be somewhere where you're recording date of transaction or whatever. I've just said date of transaction was a bit of a giveaway. Now, but date is a bit of a one that might throw you, right? Because when have we used date inside Python? We haven't, right? I dare say there will be a date library that you can make use of. Most of them do. Some programming languages, date is a built-in data type, like Visual Basic does that, for instance. For us right now, then, we actually will go date. In fact, when we've used dates, haven't we actually had to turn it into a whole number of integers? We had to like calculate the number of seconds. We did that with Snakeify, right? You multiply seconds and minutes and hours to make the total number of seconds. But there is a data type potentially. Okay. Continuation of data types. On the left-hand side, we can see here that we have a flowchart. This time it has an additional symbol, which wasn't in our previous flowchart. The additional symbol being the diamond, which indicates it's a decision or choice. Absolutely, right? And so that would and what kind of programming fundamental does that illustrate? Selection, absolutely. So in this case, it can go this way or this way. Sometimes you can have one that goes back on itself, which would indicate its iteration, because that indicates like a loop, right? Anyway, it's asking you to read through here and then say the data type of the variable age is integer. So it's giving you that one, and we can see here, right? State the data type of the following variables used in the flow diagram. So it's not asking you to tick it. You have to like remember them now. Gender, dose, and that is contentious. Yeah. Anyway, dose and is pregnant. But they've given an example where gender comes up. They've given you an example of where dose comes up, right? And they're giving you an example of is pregnant come up. Yes? All right. I want you to have a look through there and figure out what you think the data type is for each of these. So when we review all these different variables by looking over here, we can see gender equals, and there's speech marks, and then there's a bit of text in between. That, when you've got a bit of text held in a speech marks, that would be a string. What's the next one we're going to look at? We're going to look at dose. So let's find dose. Dose is over here. So it's saying it takes the value of age, which we know is an integer. If it times it by 2, it could still be an integer, right? Because if you had 16 and times it by 2, it's 32, right? But if you times it by 0.1, you're dividing effectively, then it will become, or there's a good chance it will become, a real number. So for dose, we'll call it a real number. Because if you had 13 times it by 0.1, now you got 1.3. If you hold 1.3 as an integer, what will it become? 1. If you had 19, you times it by 0.1, it becomes 1.9. If you held that as an integer, what would it become? 1, because it just chops off at the end. So obviously, using that for a dose to give to somebody, that's going to be a bit reckless, because you literally halve their dose. Is pregnant, let's see if we can find it. There it is pregnant equals true. Oops. Is pregnant equals true. Data type is true, or the alternate would be is false. True or false means it will be Boolean. Only holds 2 values, true or false. This is a bit of a jump up. In this question, it's asking us to review a flowchart, look at the algorithm, the way it works, and then rewrite it in code. And we've got 2 options. We either can use the OCR exam reference language, which we've not really looked at that much. And the reason why we've not looked at it that much is because we're going to write it in the higher level programming language that you've studied, i.e. we'll write it in, there you go. I think it makes it more straightforward. This is one of the things that changed actually for this year. Previously you had to learn, and a bunch of different things. So you see here, this is our flowchart. It's what programming fundamentals is it demonstrating? Is it demonstrating sequence? Yeah. Is it demonstrating selection? Yeah, at this point here, right? When we do selection, what is the code, or what's the programming statement we use for selection? If and else. Yeah, if and else, or if and else. In this case, we've only got two outcomes, so we can just use if and else, can't we? Are we using iteration? Are there any loops in here? No. So I want you to have a go in here of writing it out in Python. So rewriting that one out. I'm not saying it's super straightforward, but I want you to actually give that a really good try, and then we'll review. So what we're going to want to do when we're writing this code is follow this algorithm. Now, where it says start is not relevant really for us in Python, because in a high-level programming language, it'll always start from the first line of the main bit of code. So we don't need to do that. But this enter the number of minutes played, we are going to need to do that. Now, what we're going to have to use is we're going to have a variable to do that. So maybe we'll call that mins. So that's a variable I've got that's going to let me store it. And then what am I going to do? Do I set the number of minutes? How do I get the number of minutes? Yeah. I have to ask, don't I? And what command do I use in Python to ask? Just input. Yeah, if you watch my videos that are on GCSE pseudocode, that's AQA. I'm so sorry for that, yeah. So that's AQA. I don't think it'll be the end of the world. The way this will work is it will ask the question, how many minutes, and then the answer will be assigned to mins. What are we going to use to check? So for this bit here, where it's like, if the minutes is over 120, go this way. If not, so what do we say this was going to be? This was selection, right? And what do we use for selection? So we say if what? If mins is bigger than, greater than 120. Do you remember what we do at the end of an if statement? Yeah, a little colon. Then what do we do? Indent, and we say, so it is, so we say, so print, yeah, exactly. Print, and then say, you played games for too long. Because over 120, we do this, and then otherwise, what do we do? Else. And remember, we want to write else in line with the if, otherwise it's not going to work for us. Else, what do I put at the end of else? Colon, and then what I'll do is I'll do print, and what should I print? Guys, can I draw you attention to the fact that you have to say exactly what's put in here? Yes? Exactly. Genuinely, you could get marks docked, even though you got the thing completely right. Yeah, but that's when you're asked to write software, you follow the specification to the letter, and that's how you're sort of like judged for success. And yes, if you're 120 or lower, print you're under your time limit. Notice I'm following exactly what I've been asked to do here in terms of the way it's written. Also, I don't have to do anything for end. In Python, the way you indicate an if statement is ended is the indent or not indent. So as soon as I've not indented here, it's finished. In a question like this, it's essentially asking you to apply the principles of selection to the question. And it's giving you sections of code already in place, and it's essentially your job to sort of fill in the gap. Let's read what the algorithm intends for you to do. It needs you to perform the following task. Input two numbers from the user, compare both numbers, and output the largest number. Right, so this is allowing us to input num1. So num1 is our variable that is the first variable we've taken in, and num2 is our second variable, and input, like these are the commands we're doing to run it. And then it's saying compare the two. So for selection, what was the programming tool we can use to demonstrate selection? That's right, an if statement. So we're going to have to use an if statement in here somewhere, and it's saying compare both numbers and output the largest. So that's, I would say, if num1 is larger than num2, so I'm going to write that in. If num1 is larger than num2, well, what should we do? It says output the largest. So how do we output? We output with the print command. If num1 is larger than num2, which is the larger one, That's right, it will be num1. So print num1. Else. So to get down to this line, it would mean that num2 must be smaller than num2. That num2 must be larger than num2 must be larger than num1. My apologies. In which case, we need to print out that it is num2. There we go. Easy marks. In this question, it's asking you to start writing more of your own code. In this context, we can write it, we can have a little read over it. We can welcome to write this in Python, and we can have a look at this question here. It says input a number from the user. So that's using the concept of sequence and variables and inputs. Double the number inputted and print the result. So that's going to be using arithmetic operator to allow you to double it. And it's also going to ask you to do outputs using a print. So this is so far just sequence. Repeat 1 and 2, so these two functions, until the user enters a number less than 0. In that case, we're going to want it to keep looping these first two until the number is less than 0. So now we're using the concept of iteration. Iteration is when we loop. In fact, this will be logic controlled iteration because we don't know how many times it's going to go around. In that case, we'll use a while loop. But first of all, we can actually solve these first two in here. No, actually, we know it's a while loop. Let's start from there. So what do we need to do? For the logic for the while loop, we're going to have to consider how many numbers have been added. So what we're going to do is we can say, let's have a new variable here called num. So that's short for number. And let's initialize that maybe to the value of, maybe initialize it to 0. And then the command we've got while, because that is the command for a while loop. Now, what are we checking? Let's have a quick read. It says, until the user enters a number less than 0. So this should keep on going while the number is 0 or higher. So while num is greater than 0. Now, if we write it exactly like this, unfortunately, it's going to fail immediately because since num is 0, 0 is not bigger than 0, so it would terminate. But remember, it's saying, well, the number less than 0. So we need greater than or equal. So we need that symbol there. So it's greater than or equal to 0. First thing we should do is allow somebody to input their own num. So num is going to be equal to the input, and you could put a message in here potentially to enter a number, and then it asks you to output that number. So we can use the print, and we could say num and then times, and remember that's a star, times by 2. Something you might, if we were doing strictly thinking about it, is that we might have to actually, because input would take it into string, you might have to cast that as an integer. Now, because the question here, it doesn't say do it in a high-level language, I don't think you'll be caught out for the syntax, which will judge mainly on the logic. Because if you've taken that in as a string, that could be a potential problem. Anyway, we'll output it there. Then let's say they type in -1. It will output it, but then the next loop it will finish. So it will keep going until it's actually ended. Now, we've discussed before that in iteration, there's actually two types of loops. There's logic-controlled loops, which will vary in how many times they'll go around. And then there are count-controlled loops, which will go around a certain number of times. I've also used the phrase definite iteration for count control. So this is like for loops. So you know it's going to go around 10 times or 5 times. And I've also used the phrase indefinite iteration for while loops, which are logic controlled. In this one here, it's asking us to actually identify whether it's a loop infinitely or loop not infinitely. So it's asking us to review using logic control logic control loops. You can see these ones here, this one here, and this one here are all logic controlled. That one there is count controlled, so we know instantly it can't go on infinitely because the way it's written, unless there's a logic error. All right, let's have a look. So for each of the pseudocode algorithms shown below, tick the appropriate box to show whether they will loop infinitely or not. So, and here a variable is initialized at 0. While it's true, print x. So let's say you've got, zeros in here. Is true true? Yes, print 0. Is true still true? Yes, print 0. Is true still true? So it is going to go round and round and round and round and round, because you are never changing or checking on that logic control. It's always going to be if it's true, and true will remain true until the rest of all time. It's a bit confusing, I know. X equals 0. So while x is less than 10, so x is 0. So is 0 less than 10? Yes, it is. Print 0. Is 0 less than 10? Yes, it is. Print 0. Is 0 less than 10? Yes, it is. So this is going to also loop infinitely. So we'd also say that one there. X initialized to 0. Is 0 less than 10? Yes. Print 0. Or which will be x. And then x equals x plus 1. So next is now 1. Is 1 less than 10? Yes. Print 1, 2, 3, 4, 5, 6, 7, 8, 9. And when it gets to 10, 10 is not less than 10, and therefore loop would end. So this will not loop infinitely. And then for the last one here, y equals 5. For x equals y to 5, so that's going to be a loop that's going to go 1, 2, 3, 4, 5, printing x each time. It's a count controlled loop that go around 5 times, and so it will not loop infinitely. We're now looking at iteration again, but linking back to our knowledge we talked about previously around variables and constants. Julie is writing a computer game that simulates a 100-meter race. Each time the spacebar is pressed, the position of the player moves up by 1. When the position reaches 100, the player has 1. Okay, here is the algorithm, and maybe we can zoom in a little bit on it. We've got constant, so that indicates it's a constant. Remember, a constant is a value that's stored but doesn't change. That the player key equals this, and that will be indicating the space. And then position is set to 0. And in a loop, keep on looping around. So this is a logic controlled loop. So repeat until the position becomes 100. So you input a key pressed. If the key press matches player key, so it matches the space, then add 1 to position and reassign to position. Keep on going around until position comes 100, and then we'll finish. State an example of a constant and a variable. Oh, so I'll zoom back in again. So the constant, well, that was quite straightforward to see, wasn't it? The constant's this one here, right? Because it actually has the value, it actually has the name constant next to it. It's a bit of a giveaway. And we just want to write the name of the constant. So we'll write in player key. Take care to write it exactly how it's written here. So you've got, where were we? We've got capital P, capital K. You need to write it the same way it's written here. Okay. Variables are values that can change, and you can see here the main value that's changing is this value here, position, because position starts off as 0, but every time you press a button it changes. Key pressed is also a variable, because it might be that you hit the space bar, but it might be you hit the K or the L or whatever. Okay, so it could be either position or it could be key pressed. I think for us, we're going to write then position. Excellent. Moving on, it says state what is meant by selection. So what do we define selection as actually meaning? We've discussed that a lot, but maybe we haven't got a good definition for us to work on. And iteration, and using examples from Julia's algorithm. So we need a good definition of selection, and I'm going to write one here for you to learn. So our definition here is a condition is used to decide whether code should be executed. Sometimes this can also be referred as branching, so dependent on what is in the if statement. So this would be, in this case, the condition is here, right? If the key pressed was the space, so equal to player key, then add position. Otherwise, don't do anything. So in this case here, we're saying it's this section here. So this would be that position equals position 1. This line here is only going to run if the condition is met, and the condition being that that key pressed matches the space. What about iteration? What is iteration around? Iteration is around code repeating, so repeated code, or code is executed repeatedly. Can we see an example of that taking place? Absolutely. So it's going to repeat until position equals 100. So the code will repeat until position equals 100. So code in loop repeats until position equals 100. Let's continue with our questions around iteration. And this time it's asking us to write a sort of straightforward loop, or what would appear to be a straightforward loop. Using pseudocode, write an algorithm that will use a count-controlled loop to print out the numbers 1 to 10 in ascending order. Now it's worth knowing that in the updated spec, so this is a question from the J277 spec, that there was an awful lot of questions around using pseudocode. Now in the updated spec, you can answer these using a higher level language, which indeed I will allow you to do, which for us will be Python. So I'm going to talk it through how to answer this question in Python. So for this one here, you could use a while loop to do it, but I think this is more straightforward to do in a for loop. So you could say for x, so for, and then we'll have a variable called x. And then if you remember, the command is in range, and then inside these brackets, you put how many times you want it to go around. In our case, that will be 10 times. Colon, because it's the end of it, and then we have to indent. And this is the one place you can easily make a mistake. So I'm going to say print x. Now, I'm going to pause for a moment for you guys to think, but can you see why this won't do quite what you want it to do? You want it to print out numbers 1 to 10. What will this do? So, x in range 10, this is what it will do. X in the first, so let's say we've got x and then we're doing a sort of trace table of what the values are going to be. First time around it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will do it 10 times. However, it will do it 10 times from the value 0. So this would print 0 to 9, not 1 to 10. The fix will be, I'm going to just remove this here. The fix will be to just add 1 to our x. So what's going to happen is the first time around, when x is 0, so the first time it's running, 0 plus 1 will be 1. So it'll be 1, 2, 3, 4, 5, all the way down. Okay, so that's something to bear in mind, is this, it looks almost deceptively straightforward, but bear in mind that when you do in Python x equals range 10, it's always going to start from 0. It will do it 10 times, but not from 1. This is how, and it's worth reading this is how you do the pseudocode for a for loop. So let's read about how it actually how it works. So it's a for, so same as a for loop in Python. Okay, so you initialize a variable just like you do in Python, but here's what's different. You say where it's starting, what value it starts at, and what value it's going up to. So for the first loop, it will be k will be 1, and then it'll be 2, and then it'll be 3. So it's inclusive of these two values. Here it will be p will be 1, 2, 3, 4, 5. Okay, and you see also that they're nested. That will become relevant. So to do the equivalent of this in Python, you'd have to say for k in range, well, you'd have to use some of the other controls, because otherwise, if you do in range 3, it'll be 0, 1, 2. So you just something to bear in mind. Given the first three numbers that we printed by this algorithm, so okay, so we did for k is 1, p is 1, print k plus p. So the first value we're going to do will be k. In fact, let's do a little trace table so we can see what's going to happen here. So we've got k, then we've got p. I've made this way too big, so I'm going to, one second, let me back up. So let's do a little trace table, keeping track of the values. The first time around, k will be 1, so k is 1, and then p becomes 1, so k is 1 and p is 1. Then this will loop back on itself, and then p will become 2. But k is still there, as being 1, and then it's going to loop around, and this is going to keep looping 3, 4, 5 until this loop gets to 5, and then this loop will end. We'll go back to k. K will now become 2. P is going to reinitialize as 1, and then it'll be 1, 2, 3, 4, 5 again, and then it will jump out of that loop back to the beginning. K would be 3, and then can you see it would be P would be reinitialized 3, 4, 5. So in total, this is going to loop around 15 times. There'll be 15 repeats. Okay. So it says enter the first 3 numbers that we printed. So it will be 1 and 1, so it's K plus P. So it will be the value. What would the value be? The value 2. And then the next thing will be 1 and 2, because right, this is gone over, so that'll be 3. And then finally it will be 1, right, because it's still K, it's still 1, but P is now 3, so 1 and 3, so it will be 4. Then it's asking the question that we've actually just been discussing. State how many lines line 3 will be executed if the algorithm runs through once. So if it goes all the way through here. So this one, remember, it's going to run 5 times for the first when K is 1, and another 5, and another 5. In total, it's actually going to run 15 times. Identify 2 basic programming constructs that have been used in this algorithm. So we've gone over these a lot. So remember, the basics are sequence, selection, and iteration. So sequence is when we run one statement after each other and in order. Statement is when, based on a condition, we branch one way or another and execute a certain bit of code. So that's like an if and else statement. And iteration is when code repeats. Now, if we look here, can you see any place where there's an if and else statement for selection? No, there isn't. So what we can do is we can say that there is sequence, right? It's because we do things in order. So we've got sequence. We also, are we repeating code? Definitely. We've got 2 for loops. So we've also got iteration. There we go. Let's have a quick look over here. It says describe what is meant by a variable. So we're looking for a definition of what a variable is. So we've identified this many times, but it's worth taking a moment to reflect that what variables ultimately are is that they're ways of us referencing where a value is held in memory. So it's a name or an identifier, a name for a memory location. And think how much easier that is by using variables like K rather than something like saying the actual massively long address in memory where something's stored. So it's a huge saving in time. What does it do? Well, it holds a name for a memory location which holds, what does it hold? Well, it holds data. Now, so far, that definition is the same for a constant, right? Because a constant is a name for a memory location which holds data. But how can we make it different? Well, the difference with a variable is that it can be changed. This can be changed. Or it can vary. Because if it was a constant, it would stay the same. And then it says identify 2 variables that have been used in the algorithm above. So in here, where are our named memory locations which can hold data that vary? Well, hopefully we can see that K is changing because K was 1 and then 2 and then 3, and P is also 1. In this case here, where it's saying M equals 7, well, it never actually changes, so potentially you could say that that could be a constant. Of course, you could also make it a variable. So our answer here is we're going to say K and P. Ultimately, though, M could be a variable, but because you're not changing it, it could be a constant, but then you'd normally have a bit of code behind it to indicate it is a constant. In this question here, we're looking at constants and variables again, and iteration. Santos is writing a program that guesses the number of goals a team will score in a football match. Okay. Here's the algorithm for his program is below. So you have a constant indicated by the fact it says constant called noise or identifier as noise set to the value of 10. So it's assigned the value of 10. You then input the number of wins, input the number of losses. So these are almost certainly going to be, in this context, variables, because they're going to have to change based on the input. Goals is initialized as being the value 0. Your net is the number of wins, take away losses. That makes sense. And while net is larger than noise, which is larger than 10, then you add goals, and then net minus noise until that becomes that net is smaller than noise, and then the while is ended, and then the output the goals. Okay. State what is meant by a constant, so mark 1, and give an example from the algorithm below. So I can say, what we can say is that a constant is where the value does not change while the program is running. So obviously while the program stopped, you could then update this value, but whilst the program is running, the value does not change. But that's just one of the marks. The other one is to give an example, and you can see here that the example would be noise. So e.g. Noise. Noise is the example of a constant. We've literally just done this, what is meant by a variable, and give an example. So I'm actually not going to write it down. I want you to try and remember what the definition of variable was. If you're struggling, you can go back to the last question and have a quick look. Okay. State the number of goals that we outputted by this algorithm for the following inputs. Explain how you obtained your answer in each case. So in here, we need to say the input of wins is 30, losses is 25, and we're going to have to go through how what happens. So in this context, net, in fact, I might just do a quick. So this would be an ideal place to actually do a trace table. We've got no real space for it. So I'm just going to record the values that change. So net is wins minus losses. So in this case, net will become 30 minus 25. So net will become 5, right? So here, net becomes 5. And then it says, while net is larger than noise, so net is 5, noise is 0, and noise is 10, so that's not larger. So we can say 5, is it greater than 10? And the answer to that will be false, right? So it's not going to run it. So therefore the while loop will never run, and then it says output goals, and goals will be 0 because it never changed. So we can say state the number of goals. So yeah, goals is going to be equal to 0. Right, let's do the same thing again, but this time wins is 20 and losses is 5. So net equals wins minus losses. So let's do that again. So net this time is actually going to be equal to 20 minus 5, so it's going to be 15. And then we've got 15 greater than 10, and that time it's going to be true, right? Because 15 is bigger than 10. And that means we're going to run this loop. So goals equals goals plus 1. So now goals would become 1 equals 1. And then net equals net minus noise. So now the new value of net is going to be 15 take away 10. So net will become 5. Now because net is not so we've got so we have to go back to the while loop. So we say is 5 larger than 10, so that would be false. And now the outcome is going to be, and then the output. So that means that the final output is that goals is going to be equal to 1. Okay, now we're looking at a question which is making use of a trace table. We discussed that earlier, and we said it would be useful to trace in the variable, the values of the variable as it changed, and now we're going to make use of it. Essentially, the way a trace table works is that you've got the variables that you're going to be using inside your algorithm, like x and y, and you're tracking the values that they change to as you run through your code. So this is the algorithm we're going to use to trace it. So the first thing that happens is x becomes 15. Well, guess what that means? We're going to put 15 in x. We then work through our algorithm, and then our trace table works like this. It goes across, next line, and as you make a change, you update the value. So the next thing is that y equals 0. So we're going to say y equals 0 there. And we keep tracking across. We look for the output. There is no output yet because we're coming back to the algorithm. While x is greater than 0. What is the value of x? 15. So it is going to happen, right? Because 15 is larger than 0. Y equals y plus 1. So y equals y plus 1 means that now y becomes 1. And x becomes x equals minus y. So x will be 15. Take away 1 is going to be 14. Now, you can make it neat and write it here, or if you're writing in order, you can put it here. I'm going to try and make it neat, 14. We then come around. While x is greater than 0, is 14 bigger than 0? Yes, it is. So we'll keep on going. Y equals y plus 1. So y equals y plus 1, so y becomes 2. Here, then, this is sort of a place where you can go wrong sometimes. X equals x minus y. You might be like, it's 14 take away 1. Now remember, you have to use the most updated version of y, which is 2. So 14 take away 2 means that we have 12. It's then going to go around again. Is 12 bigger than 0? Definitely. Y equals y plus 1, so y becomes 3. And then in here, we'd say 12 take away 3. It's going to give us 9. And then we've got y is 4. 9 take away 4 is going to give us 5. So we're still going, aren't we? Because 5 bigger than 0. Then y becomes 5, right here. And then 5 take away 5 is going to give us an x of 0. And now when we look at it, it will say, while x is larger than 0, 0 is not larger than 0. So finally it says print y. So the output would be y, which would be 5. Brilliant. We've encountered this flowchart already. It was right at the start. But now let's see our new knowledge being put into action. So this was the algorithm, I don't know if you remember, but it's the one that allowed you to take in a first name and a surname and sort of generate a username based on sort of cutting out some of the characters. It was taking out the first 3 letters of the first name, the first 2 letters of the surname, and then it made a username. Now there's a little bit of a tweak. Johnny has updated the process used to create a username as follows. If the person is male, then their username is the last 3 letters of the surname and the first 2 letters of the first name. So we're using selection. If the person is female, then the username is the first 3 letters of the first name and the first 2 letters of the surname. What would the username be for a male called Fred Biscuit? Use the updated process. So is it male or female? It's male, so we'd run this bit of code. Their username is the last 3 letters of the surname. So the last 3 letters of the surname is U, I, and T. I can zoom into this, make it a bit easier to see. There we go. So the last 3 letters is U, I, and T. In fact, maybe I can even highlight that and make it a bit easier to see. There you go. So we do that. And remember, it's very important we follow all these conventions. So it's U, I, and T. Lowercase u, I, T. And then the next one is the first 2 letters of the first name. So that would be F and R, right? So I'll highlight that as well. There you go, F and R. And we'll follow the convention of the capitals being that way around, the cases. Brilliant. Okay, now it's saying write an algorithm for Johnny to output a username using the updated process. So this is all about using selection. So what we want to do is we want to allow some of these things to happen. So what's some of the things we need to do? Well, we now need them to input their first name, and we're going to need to allow them to input their surname and input their gender. So let's do that first. So we've inputted their first name, their last name, and their gender, and then we need to check their gender, because based on male or female, they'll have different outcomes. So to do that, we'll use an if statement for selection. So if gender equals, and let's say we'll do, I don't know, we'll start with male, for instance. We'll do in here, and we can say we're looking for the string male. and then we can do some stuff. Now, I've just made a deliberate error on this line here. It's a syntax error. Can you see what my deliberate error is? That's right. A single equals is assignment. See? So I'm assigning whatever the input to first is, assigning whatever the input to last is. This is for a single equal is for assigning a value. I'm not assigning male to gender. I'm checking, I'm comparing whether the value held in gender is the same as the one in male. To do that, it's double equals. Okay? So what do I need to do then? Well, I need to generate the username. So the username, right, is going to be 1 second. It's going to be equal to this thing here. So it's the last 3 letters of their surname and the first 2 letters of their first name. So to do the first 3, we did left, so it's on the left side. Now we're going to go on the right. So we'll type in, so is equal to right, the function right. And we're going to take in, sending it, the last 2 letters of the surname, so we need to send it the last, so the surname, so send it last. And then it was the last 3 letters, so we'll have to send it right, and then last, and then the value 3 to take the last 3. And then we want to plus, and I'll do it the line underneath, left, because we're doing the first. The left is the first 2 letters of the first name. So we'll have to send left, and then we'll have to open a bracket. Then we'll have to send it first, and it's the first 2 letters. So comma, and then the value 2, and there we go. That's it for male. Then we'll have to do the right one for female. So in this case, we'll do else, and then colon. And we have to do a similar thing. We'll have to do username, right? And then we'll have to think about how we're going to construct it. Well, let's have a quick read. So for female, the username is the first 3 letters of the first name. The first 3 letters of the first name. So we'll do left. We'll send it the first. So we'll send it the first name. But it's the first 3 letters, so we'll send it the value 3 to get the first 3 letters, plus, and the first 2 letters of their surname. So plus, and it'll be left again, because it's the first 2, left. We're going to take the first 2 letters of the surname, so left, and then send it last for the last name, comma, but it's 2 letters. Brilliant. And at the end of it, we're going to need to output that by using print. And what are we outputting? We're outputting the username. So we're outputting the username. Great stuff.